any relevant information, it's much better. What I want you to submit at the end of this activity by having some sort of a short report that relevant to the case selected, and the case selected must be comprises all these informations. And I hope that you can have your own explanation on each slide presentation, and also you need to convert it into the video, and you have to what I said here, by submitting your short video through giving a feedback from this activity, so I know that you have attended for the remaining 2 hours. So all those videos submitted to here in future will be uploaded to my YouTube channel, and I hope that you can subscribe the YouTube channel so you can evaluate your self-performance presentation online or through the video presentation. So what I'm going to use this approach is due to the some reasons that I think that you all are very familiar with this what we call it video maker, and then IT video contents apps. So you can have this kind informations by posting to this media social, by delivering good informations about geotechnical engineering, but we focusing on the failure. Okay, do you have any question on this part? Ada soalan tak?
No, madam.
Okay, is it clear? We haven't started our lecture yet. It's just explanations how I'm going to conduct these 3 hours lectures, because the case study approach is some sort of actually you can have a good idea on what you are facing when you having a hands-on experience through the site, or you might face by conducting a lab investigation, or also through the preliminary report. You are reading a preliminary report, and then you are reading on the post failure report. That are good things, meaning that we taking from the past experience geotechnical engineer. They reported all the failures and how they mitigate the problems. So now you replicate the same approach to make your own. But in a way, is that some sort like I am reading to you during these 2 or 3 hours, getting bored. So I hope that you can have your personal or your own investigations, how to start off finding a root cause to this problem, and how do you come out with solutions to mitigate all these failures. All of you know that the failures can occur, I mean that immediate failure or post failure, or it can have during the constructions. Talking about the failures in geotechnical, I think that if you look at to your weekly lesson plan, in civil engineering, there are many branches involved, from the structural, and then we have constructions, we have also geotechnical, we have also pavement. So in the topic, in the chapter 3, we might deal with the hazardous in geotechnical engineering. Later on, last topic will be focusing on the pavement or highway failure. So you might see that some sort of crocodile cry on pavement, or that one will be in the topic 4. In topic 3, we will face a few cases that focus on the geotechnical failure, such I mentioned just now, settlement, bearing capacity failure, deep mining failure, and then other things that might causes to the loss of lives, and then it might cause to the impact of the socio-economic, etc. So I hope that you can have some textbook that can be referred, because the notes that I show later on, that I show later, will be some kind of the short notes. Might not what we call it here, to give a full explanation what exactly the notes try to explain to you. Okay, before that, let me show you a simple video that telling you what's exactly forensic engineering in geotechnical discipline. Okay, let's see one short video.
Tugas ibu memang penat. Tapi kadang-kadang kita lupa. Mereka yang banyak tolong kita.
Okay, iklan Sat.
Ada cara mudah untuk gembirakan keluarga. Mayonis sebenar Ladies' Choice. Buat sama-sama, lagi menarik.
Geliyor. Yani rica ettim ya gelir aşağı her yerden geliyor burası. Bizim makine kurtarma şansımız yok. Bırakalım bile gelecek. Ya git abla git ya. Bunun makinesini abla git. Kameraya çekin şurayı ya. Sen al işte makineden çık istiyorsan ben alıyorum. Bırak şu makineyi yere atsana bırak. Biraz yere. Ocak yıkıldı. Bak abi o bina gelir abi.
Okay, so who wants to share what have you seen? Okay, anyone would like to share what have you seen or what the first cause triggering to the deep excavation failure? So I'll just pick up any names. Is it okay? Okay, let us hear from Muhammad Irfan. So imagine you are we call it a forensic guy, but from geotechnical divisions, came to the site. You are appointed by public authority to have some kind of investigation to determine what are causes to the failure, and later on you need to propose how are you going to mitigate or how are you going to solve the problem. Because now some problems or failures can occur during the construction or post constructions. It can take years after that. But then in order to trace back or to return at the current of year constructed might not easiest way to find the informations. So how are you going to deal as a forensic engineer? You have to play a good role in order to give a full informations to the public authority or to the client appoint you to be a forensic engineer. So what do you say, Muhammad Irfan? How are you going to do? Do we have Muhammad Irfan here? Hello, Muhammad Irfan. Okay, I'm assuming that Muhammad Irfan is actually not present in this online class, even though he had logged in or he had joined the class. I am not sure whether he had a internet problem, but I assume that he's not attended the class. Okay, not to forget about your attendance. I'm going to use UFuture to record your present during the online sessions. So please log into the UFuture and tick for presentations or your presents during the class. And if you're not doing 15 minutes early after class started, you can do 15 minutes after class end. So don't forget to tick your the presence of yourself during the online sessions. So I think that Mama Irfan is not in this online class. So let us go to anyone. Nur Alia Balkis, do you have anything you would like to share or say about this problem? Because if you look at to your group project assignments, you are only given what we call it here a building. So if you want to start an investigations on forensic, it's not on such as one section or one discipline only that you need to focus. You have to look at as a overall picture of the problems. For example, you were assigned to investigate to do some forensic engineering at College Delima, for example. What are the things that you want to see? That's parameters or some input that leads you to what you are doing. If you are not preparing from now, or you are not taking seriously from what you have learned in the topic 1, chapter 1 and chapter 2, and then we are heading to the chapter 3 and chapter 4, without knowing what you are doing, you might produce a bad report, not represent a forensic engineering report. Because when you go to the forensic engineering report, it's not similar to what we have a site exploration report. It's some kind of inclusive that covered all civil engineering problems, such as if you are dealing with a problem in College Delima, what are the most causes or failures that you can see or it can be observed on site. For example, structural crack. And then how do you relate the structural crack to the geotechnical investigations? Or if you want to focus on the structural failure, it's not complete, it's not enough, because as you know that the structure located or standing under, the structure standing on the soil. So the subsoil beneath the structure itself can be a cause to a problem, geotechnical problems. How are you going to start the investigation process? Are you going to investigate by doing some other soil explorations? Or you might some kind of having some surface engineering investigation by taking a sample and then do a lab testing and then do some report. And how do you do that? What kind of analysis design that you may propose in order to prevent any future failure? So these are the processes involved during preparing a report. Or not other the report, you also involve the initial step in the forensic engineering. So anyone would like to share your thoughts or idea? How are we going to state, or how are we going to relate what you have seen from the YouTube video regarding the deep excavation failure? What are the first thing that you can capture during the failure? Nurain Fasiha. Is it Nurain Fasiha also absent today?
Ada, madam.
Okay, what do you think, Nurain Fasiha? Do you think that it's just quite similar with structural failure, but the thing is that now in geotechnical applications, you can see that just now on the deep excavation. So what first thing you might seen from the video? Do you have any idea?
No, madam.
Okay, who wants to have her? Apa nak tolong dia? Actually, when you read a paper, the failures, some kind is not being highlighted as related to geotechnical engineering failure. It can be a very common what we call it, disasters or natural disasters occurs. But the natural disasters also a part of the forensic engineering. So that's why when you registered the course, it's not focusing on the structural failure or whatever. So it just highlighted as a forensic engineering, meaning that when you are investigating the main cause or the root cause, you have to look at through all pictures of the failures. Is it relevant? Is it related to the structure? Or is it related from the beginning of the construction began? Or it can be due to some reasons on the subsoil itself, or it can be happen due to the anything. So when you are doing the forensic, it means that you have you seen any what we call it drama series, crime scene investigations, Florida or Miami. That's the process how this police detective did their CSI. They went to the site, they investigate or they find anything that may connect to the case. For example, such as if you are dealing with this kind of the slope failure, so you need to find what are causes to the slope failure. Is there any slip failure occurrence can be seen on site? And then if you can see a slip circle, where you need to identify the type of the slip circle, either rotational, translational, two circle, uh, or or circular circle. And then what are causes that bring to the failure of the slip of the slope circle? For example, the strength value. Is it use the drain parameters or undrained parameters? This how you take in all the informations that you have gained through your lower level, and then you write up in your forensic engineering report. So without this, you couldn't do a proper report that telling you what are causes, and then what are theory involved, and what are design and analysis to being carried out throughout the report preparations, and what are the mitigations that can be proposed to your public authorities. You need to also cross-check the guidelines given by the public authorities or any authorities body, and then you have to see also the guidelines and the design itself can be suited with your proposal drawing or proposal solutions. So lastly, you have to check on the community sensitivity or any community issues such as environmental impact, and then traffic congestion. And these are the things that you have to look at in all every angles. It's not that okay, I am doing this kind of the structural failure, or I want to concentrate on the structural failure itself. No, you have to come out what are the things that can be connected to the structural failures. The structure is standing on soil, so you have to relate also what are the parameters from the soil that can be linked together with the structure itself. I mean that if you have low bearing capacity of the soil, you might have also some chances of the structural failure. So I think that you have to read a lot about the forensic engineering. So let me share to you what we're going to learn this afternoon class. Okay. Okay, all of you are in part 7. So I hope that I mean that you can share your thoughts or what do you think or any opinion regarding to the topic, because this topic is on the case study based approach. It's not something that meaning that and the teaching and learning methodology is mostly close with the discussions. So either you have a group discussion or you can have a discussion to lecturers or any relevant such as civil engineers or consultants or anybody that you prefer to have some kind of thoughts, because investigations or this what we call it, this course is not on totally on books, because it need to consider, or you need to take from one case, and then how do you analyze the case in order to understand what are important things behind the issues. Okay, the learning outcomes from this topic, or from this chapter 3, you will be able to investigate and analyze geotechnical failures, and able to formulate likely scenario for geotechnical failure and develop rectification measures. So as you can see here, so these learning outcomes map to the PO2 and PO5. So PO2 and PO5 for you in EC 221, and based on outcome-based education, is something that you have to investigate and analyze. Talking about analyzing on this matter, you need to have some kind of geotechnical parameters, geotechnical characteristics, geotechnical properties values. So how do you analyze it, um, to have some post mitigations, or you want to back analyze according to the information that you gathered from the site, or you have from the secondary data. Okay, rectification measures. Rectification measures is closely to the solutions. What are you going to propose to mitigate the geotechnical failure? So the problem that come with the solution must in line with the guidelines given by the public authority. So when you are proposing a solutions, make sure that it is applicable to be constructed on site. So avoiding any future failures or hazards. So these are the types of geotechnical hazards. So this is also a textbook that you may refer for future for details or further readings. It's very helpful because, as I said again, later on you might see that some notes given here are very short taken, not in detailed explanations. So in order for you to have a full explanation, what's the thought, what the notes given here, please read from this main reference. So as I said just now, your learning activities are splitted into two groups of geotechnical hazard. For example, you have to deal with excessive settlements and also bearing capacity failures in the week 6 and week 7. And the next week 8 and week 10 will be on excavation failure and also the slope failure. In Malaysia, mostly we may encounter slope failures or landslide or debris flow. If I'm not mistaken, you can take any past case history, such as what we had in Yan, for example, the news written on paper mentioned that the landslide or the massive flood due to the kepala air. So you can take that case on paper to be your forensic case history. And then how do you start investigating work from the beginning to the end? Okay, when we talk about case histories, so all the case histories may have some kind of combinations, failures, or it can state on one type of failures. So each case histories for each type of failures. It says that if you go to that textbook, you can see that it tried to present one sections for one case history, and you will see that the approach to readers by following sections through case description, relevant theory, mechanical analysis, mitigation measures, and also the lastly is a lesson learned. So when you go details in the textbook, you can see that whatever cases are written or highlighted by the authors, all 5 items are there. So you can see that how it is started to explain or to give the informations regarding with the case selected, and then how it is relates to the theory behind the behind or future analysis involved, and then what are the mechanical analysis involved. The next one is a mitigation measures, and lastly is a lesson learned. As I said, when you are doing the forensic engineering, it is good if you have some sort of the on-site experience investigation. You go to the site, you do some sampling, and then you bring the samples to the lab. You start doing the testing from the beginning physical test, and then you do the mechanical test, and you do the analysis, and finally you come out with the full report. So the full report also can be extended to the next prediction using the numerical software. So you can predict for the future estimations on the failure, for example, or you can back analysis to look at whether this kind of the strength parameters can trigger to any kind of the failures. So these are the good things about the numerical modeling and simulations. Okay, we go to the first case history stated in the textbook. One is the differential settlement. So it takes or it refers from this kind of the building called as the Metropolitan Cathedral Sagrado Parish Church in Mexico City. So it's not the city does not belong to here, but again, as I said, if you want to understand what it's all about, you have to read from the textbook or read from the notes. But the things this case history is highlighted on the differential settlement. Talking about differential settlement, you have to understand what is the differential settlement and what are causes that trigger to differential settlement. When it says that differential settlement, something, for example, if you have a column that's located in the zone A and then column located in the zone B, for example, you can see that the column A and B will settle differently. For example, column A carrying a maximum load, meanwhile column B carrying a minimum load. So the difference between the carrying load from zone A and zone B can give you a different settlement. And also, it is depending to the soil profile, soil properties. So if you go to here, you read from the case description, it's all about is a monument, and then it was built in the 16th century on soft lacustrine clays over the remains of ancient Geotechnical, the lake of the active empire. So for me, what I want to highlight is the geotechnical properties. This is the important things, soft lacustrine clays. So if you find out from this online website or anything, you can see what are properties on the soft lacustrine clays, how it is behave from the permeability, compressibility, and also its strength. You can see that the soft lacustrine clays actually it can contain high water content. And then if any other for the future, or what we call it, if you go back from the present days to the past 16th century, for example, you can see that there are a lot of changes in terms of the environment, in terms of the soil itself has been weathered. So in order to investigate on the geotechnical hazardous failures, it's not easy. So during the time, the present days, what we want or what we can do is only rely to the reported data or published article that that give some informations regarding to the issue or regarding to the site you are investigating to. So how it is started, how it was started? It was started by having some kind of the large differential settlement that adjacent to the metropolitan accumulated over the centuries and presently threaten the stability of the structures. Somehow the structures can be found or being threatened when you see any crack failures on the structures, on the cracks on the structure surface. So that is indicators the structure has been subjected to failure. And then when you do some details investigation, finally it's come up with the soil settlement. Most occurrently, the structure failure or any kind of the crack failure is due to the settlement. How do we improve? Oh, sorry. How do we prove that what our hypothesis, our statement that relates to the settlement? So this is what we call it investigation. You do the investigation works. So you're checking what's the definitions of investigation. There's a lot of processes involved. So it's not something that one step process is finished. No, you have to do some step 1, step 2, step 3, identify the most the initial step to the final step, and these are the things involved during the process of investigations. So the stability of the structure, what they afraid of, the structure or the building may collapse. So we try to prevent any historic building or any architectural monuments from failure. Okay, when they did on their study, take it back from the recorded the soil stratigraphy, the soil profile. So this explain to you what are the causes that trigger to the settlement or the structural failure or any structure stability. So you can see that this kind of the what we call it geology history of the site, and then the explanation or the case description explain to you how it was started. The construction began in 1560, and its shallow foundations rest on artificial fill layer placed over alternating thick layers of very saturated lacustrine clay and sand. So where is figure 1.3? So this is the figure 1.3. So when you are reporting your forensic report for your project group, it is good if you can include also the soil profile. As at least we can understand what's beneath the structure, what type of the soil below the structure itself, whether it is consists of strong or hard layers of soil, or it is a weak or very soft soil. So from this one, we can see that on the left and the middle of the building, we're having different of soil properties at the different depth. So this is also the explanation. It says that the foundation is located on the artificial field. So when you have the artificial field, which is not located on the original or the parent rock or the parent soil, there's a possibility the structure will be not stable. Because if you have any kind of construction and then you do some field embank or field work, earthwork, so it is not bringing to the original properties of the soil. So we are not sure what's artificial field characteristic. Is it capable to carry the maximum load? So these are the things that when you are deciding to have some field earth material, you have to consider, is it the soil layer with a certain volume can be carrying the maximum load from the structure. Other than that, when you look at this information, the foundation is built on 3.5 thick basement made from a grid masonry and beams placed over a 2-meter thick layer of rock masonry which rests on 30 centimeter thick grid of short stakes. So these are the information. Actually, when you read on this case description, for you, you can see that this case can be a cause to the failure itself. So it had a basement, and then the foundation system was borrowed from existing local Hispanic practice. So as I said again, when you have a borrowed or filled as material, what are the things that might bring to you in future? Is it safe or unsafe? Okay, and then this is the details on the site plan of the structure itself. And then here on the right side is a pattern of differential settlement measured in the floor of the cathedral. So another important thing is on the stress pressure, overburden stress, effective vertical stress, and then what are the stress history, because the vertical stress, the overburden vertical stress can be calculated from the loaded applied on soil, and also you have to consider the stress history from the clay itself. So it shows here that how they transform from the plan view of the building that relates to the actual with the what has been reported in 1,500 years ago. So this is the stress point at A. You can do some calculations on the effective vertical stress. So now we go to the analysis. So it says that very simplified analysis model, but then it relates to your basic soil mechanics knowledge, such as how do you calculate the contact pressure at the point A, and then what kind of the loading at point A, is it rectangular, square, how do you calculate the stress concentration at point A due to the load here, because the load is not located on point A, it is located few meter from A vertically and few meter from A horizontally. So then that meaning that it comes back to your understanding how do you do some calculation on the contact ratios. Not to worry, because this case history also shown to you the calculations involved using the simplified structural model, showing to you A is a plan building and the B is a contact pressure, how it changed that from this kind of the loading M1, M2, and then how it transformed the cathedral loading into 166 kilonewton Newton per square meter, and the pyramid itself, and you want to do some calculations, and the next involved is the consolidation calculations, converting the loadings contact pressure as a Q and apply on the clay itself. Because from the case description just now, it says that the foundation is founded on artificial field with the height 12 meter. Then baru you akan nampak 3 layers in clay, 12 meter each. So the clay itself is unstable, meaning that if you look at to the clay properties compared to the sand you can see that in terms of the modulus or the stability, in terms of the stiffness might be different between the clay and sand. If you compare more to the rock itself, we can say that all those between clay, sand, and rock is more stable. That's why for this kind of problem, you have to find out what are the foundations of the structure. Is it rested on the rock, or is it rested on clay, or is it rested on sand? And then again, as I said, if you are not doing on the soil exploration investigation, what can help you is that getting the information from the past record. So you have to collect from the public authorities. You go to the library, find out the informations about the building, and then contact anyone that can give you the informations regarding to the case history. So after having this desk study or site exploration, the next thing is that we do analysis on the consolidation settlement. One of the important things about the calculation of settlement is the void ratio. And then we need to know the pre-consolidation ratio. And we need also know the consolidation index, volume of compressibility, MV, CC, CR, and then the sigma BC. So all those things are very important to give you what are the last calculations of the settlement. So in this case history, it shows to you that the initial void ratio is a 7.0, and then the compression index can be calculated as what you can see here, having from the initial overburden pressure to the final overburden pressure, and the compression index is equal to 5, and then the what we call it, the reconsolidation index is a 0.5. So I hope that you are very familiar how to plot this curve. I mean that E versus log stress. So the E versus log stress only can give you all those parameters, the CC and then the sigma PC. What are importance about this parameter? Because you want to calculate the settlement. So look at to this one. Okay. Okay, this case history or this note is not given you the calculation of settlement. So I think that you need to take a textbook, find out what's exactly the formula for to calculate the settlement. The next one is on the settlement due to consolidation. So I think that this one is just I give you some explanation how it is involved with the stress history from the stage 1 to the stage 2. The stage 1 is actually the pyramid is built and removed, then the ground is level and the cathedral additional stresses is built, and then stage 2 is when the ground around the cathedral is level and as a effective stresses additional S is built. So there are construction stages involved. For the stage 1 and stage 2 are totally different. It shows you how it is constructed from the one stage to the next stage regarding to these buildings. And then when you are dealing with the different stages of the constructions, they will tell you different stages of the effective stresses involved. So you can see that from the left side of the stress curve, E versus log stress, in the middle of E versus log stress, it shows you that the changes of the stress from the first one to the middle graph and to the last at the right side of the graph. To the right side of the graph, you can see that the changes of the effective overburden stress and effective stresses, final stress involved when you have dealing with different stages of stage 1 and also the stage 2. So you can see from here the calculation of the settlement in stage 1, stage 2, and finally it presented in the table how you can see the differential settlement from cathedral and El Sagrario for stage 1 and stage 2. You can see a huge difference in the present calculation and also measured in 1990. Because you can see that when we read from our understanding of the consolidation, settlement can be defined from 3 types of consolidations. The first one we call it as a initial consolidation. The second one we call it as the primary consolidations, and the last type of consolidation is the secondary consolidation or creep. So that's why it says that when you go into depth to investigate on this case history of the cathedral and El Sagrario, you can see there's a differential settlement values from the past in 1990 to the present and to the future predictions of settlement. Because of this, it will be changed according to the stress effect, the stress history, the effective stress acting on the soil. So as we want to relate is that the stress will be differ, will be given you different value compared to the present and past due to the what we call it here is weathering process. The stresses also change. Let's come to the stress history. So when you dealing a problem with the clay, the most important part is to know what is the stress history of the soil. You have to find what is the pre-consolidation pressure, what is the initial overburden pressure, and compared to the void ratio, the pore water pressure effect, and the hydraulic conductivity, permeability, and etc. So that's why I said in this text, in this note, it's only given to you a short understanding how was the case history being processed in investigation for forensic. Okay, now it shows you that the settlement can be occurred due to the groundwater level. So of course, the groundwater level will be changed accordingly to the years. The time during construction will be not similar to what we may have during the present days. So due to some drop in the value, there will be some existing differential settlement. And it causes a uniform stress increment delta sigma g under both structure due to the points react to this stress increase differently. So the explanations of the pore water pressure effect can be seen from this stage number here. So just to tell you, when you want to do some future predictions on this issue, for example, there's a staged constructions involved. We have to split our processes into few stage in order to get the calculation analysis. So we have the stage 1, we have the stage 2, and we have the stage 3. The each stage will tell you different stresses values. You can see that the changes of the stresses will give you changes in the stability and deformations. You can see now, this is also, if you involve with the drop in groundwater level, you can see the differential value in present days and also in the measured 1990. So it says that what happened now is due to the long processes involved from the after being constructed to the present. There may be some changes to the structure and to the subsoil. Okay, this kind of the discussion that can be included, for example, that the simplified geotechnical model of the problem cannot claim the exact predictions of differential settlement. So it's only focused on the effects of interactions of the neighboring structures, loading history, and the global and local drop in the water level. So it's only highlighted 3 causes. So the first cause is the structure. Next to the point, maknanya you calculate the contact pressure, and then you look at to the loading history, and then you take it one cause is due to the groundwater level effect. So other factors causes maybe can put also in the analysis or in the report, but we are not sure why it's not included here, maybe due to limited information. So the smaller than predicted differential settlement of the cathedral may be attributed to the correction measures carried out during its construction and later. So this simplified model, however, has been sufficient to achieve qualitatively correct predictions of differential settlement of both structures of meaningful order of the magnitude. So it demonstrates the power of the simple geotechnical analysis in understanding the complex process behind the some geotechnical failures. So after having done on the analysis, you need to come up with the mitigation process. At this particular case, it is proposed by using a perforated hose. It tries to giving a water flowing up from this subsoil. So you can see that this one is a perforated hose provided by some of the tube here, and then you need to do some under excavation below the structure, and you have a vertical shaft. These are the processes involved in the mitigation works. So during the construction also, you need to prevent any failure, because remember, when we are doing the mitigation, the existing structure is there. How are we going to prevent any structural failures? And then we need to do some details work. I mean that propping presses, or we have the proper sheet pile, we have a proper deep excavation that can be avoiding from future failure. Okay, I think that this one you can read through. It proposed by excavation first at the certain level below the foundation. Remember, it is in plastic clays. So some dimensions of the perforated hole in the soil mass produce a surface settlement. So this hole collapsed and a new one is penetrated, so the settlement increase. Yang tu yang common we might expected from what we have on site. So the volume of excavated soil give rise to control settlement, allowing corrections of distortion in the structure. So it says that by doing this, it tries to balance between what they have found from this differential settlement at one location to the one location. So the goal of under excavation has been re-established the condition in 1934 to allow for comprehensive refurbishment of the cathedral. So the end-day excavation likely to be repeated over 20 to 25 years. Remember, the case history that I presented just now is on the historic building. When it says the historic building, we have to do some long-term mitigation work or frequent or periodically mitigation work. It's doing in certain durations. So it's stated here, what it has been done in 1990 can be replicate the same thing or can be done again for the next 20 or 25 years, because we want to prevent the historic building from collapse, because this is for future generation purpose. As they can see, or when they talk, when they say about the monument, when they say about the old museum, so they can see by their eyes. It's not on through the written words. So it says that good things about mitigation, it can be seen also in the future for anyone who likes to see real building. And besides having the perforated holes, it also grouted injected using hydraulic fracturing that will be reducing the yearly displacement by an order magnitude. So there are other things can be included during the mitigation works. So these are the things I think that it shows in the early is on the floor plan of the building, and then a plan of the failure. Later on, when you come out with the mitigation work, you can highlight a few spots that you have proposed to do a remedial constructions or remedial work. For example, this one. So yeah, it shows that on the A side or at the left side figures indicate the positions of the hydraulic fracturing, and through the plan, the floor plan, you can see on the injected areas being applied to the building. Okay, not to forget, when you talk about forensic engineering, what can be taken as a lesson? Why we have to propose or why we have to highlight a lesson that can be learned from the past history or from the past case history? Is it due to we want to prevent any future construction work repeat the same problems or repeat the same mistake? So when they come out with this lesson learned, at least you are, as a future geotechnical engineer, wherever you work, you can take this one as part of your self-experience. Somehow, the experience cannot be taught. You have to experience by yourself. But somehow it can be learned through by reading. So that's the purpose. Some history or failures write on the lessons. So there are three things that can be highlighted from this case on the loading history. For example, distance between the neighboring structures and the regional subsidence. So these are the things that are causes to the failure. For example, the history of the previous construction and the sequence of the current one will largely determine the pattern of the differential settlement of the neighboring structures by changing the compressibility of the soil foundations. It says that loading history, when you want to build a building on the clay itself, we want to prevent any differential settlement, you have to check on the stress history of the site, the stress history of the clay. Is it over consolidation, normal consolidation clay, or is it NC or C or under consolidated clay? So these are the things that we try to highlight. So the differential settlement, again, maybe due to the difference loading history. And other than that is the distance between neighboring structures. You might suggest that the building of the structures can be in certain meter. These are the things that we try to highlight. For example, here, distance between the neighboring structures is of crucial importance for the magnitude of the interaction effects. So due to the fast attenuations of stresses, with a distance, sometimes a moderate increase in distance between the neighboring structures can reduce the interaction effects to being small or negligible. It says that from this meaning, you have to identify the best length in distance when you have a close building that carrying the same functions. What will be the best one? And then what are the by determine at first process of the soil profile, and then you know what's the loading of the structure itself, you can locate the distance in your design and analysis. The next one and the last is a regional subsidence. Thought conventionally considered to be a source of relatively uniform global settlements only, the regional subsidence can cause differential settlements due to spatial variability in the compressibility of soil, resulting from a specific loading history. So when you look into this one, the most what we call it, the most complex and problematic in geotechnical engineering, when you found a structure will be a structure built or will be built built on the clay soil or on the soft soil. What are the things that you may expect from the type of soil? For example, settlement, and then you may see also high water level. You may see also the bearing failure and other things that relates to the consolidations. Okay, this is the additional reading suggestion. And how do you do investigation or by having some kinds of problem related to the settlements? Okay, bearing capacity failure. Bearing capacity failures is on about the foundations. So I think that it is very common if you are doing geotechnics course. In the geotechnic course, if you had taken, of course you have taken right the geotechnic course. Remember that how do you do the calculation on ultimate bearing capacity, and then you calculate on the factor of safety, allowable bearing capacity. So these are the similar things involved. Before that, you need to know the contact pressure, the Q. What are the contact pressures either in mat foundations or strip foundation or rectangular or circular foundations. So these are the types of contact pressure. And again, it's very important to have the soil profile. And then the strength of the soil can be obtained from cone penetration test or from JKR probe test, or if you have more money, you can conduct standard penetration test. And then look at to the failure. Is it the structural failure tilt, or it is totally rotate, or it is totally settled? Remember, when you are doing the calculations for foundation stability, there are three types of the modes of failure. First is the general shear failure, punching shear failure, and also local shear failure. All those failures can be bring to you on part of the foundation stability. The stability from overturning, stability from the bearing capacity, stability from sliding. So if say that you are doing bearing capacity failure case, so these are the things that you might involve in the design analysis and calculation. Okay, now as I say here, choose one theory. Is it Tzatzi? Is it Meyerhoff? And then what are the bearing capacity factor, NC, NQ, and gamma? Is there any inclination factor? Is there any shape correction factor you need to do? And what are the mechanism of the failure? Is it involved with the homogeneous soil or heterogeneous soil? And then what is the this is really related to the contact pressure, because you can see that the M and N here, and how it is guided you to do some kind of design and analysis. This is the thing, for example, what are parameters involved? What are the theories and characteristics, the soil strength, and lastly, how do you do the mitigations work? So it is suggested a few works for mitigation, such as here, you can see that emptying of the elevator, or you do the underpinning of the workhouse. It is common to conduct on underpinning of the workhouse. You can read by yourself. Okay, how they do the underpinning. Okay, what are the lessons learned that can be taken from this case history? The first one is a site investigation. Why it is highlighted the site investigation in this case history for bearing capacity failure compared to the settlement? Why site investigation is very important? As you can see that, as stated here, of course, we know that for initial any construction work, the first information that we can do before having a design and analysis through the geotechnical site investigation report. So the fact that other similar heavy structures in the area were founded on similar foundation did not have a locally weaker clay layer located below the typical stiff clay layer mess up all the analogies. So throughout the site investigation, we can understand the behavior of the soil itself. For example, you are constructing a large structures that carrying a maximum load. Is it possible to being built on the clay, for example, very soft and very weak clay, and then the weak layers is not having any hard layer or any bedrock? There can be more problems to the structure, to the foundation itself. And then looking to the what type of foundation being used. Is it deep foundation or shallow foundation? If you are constructing a warehouse, most of the time the construction will be constructed using a mat foundation because it's a large area. The floor area is a large, so we can use a mat foundation. But then, is it your decision is correct when you encounter a soft clay layer? Is it possible to use matte foundation instead of using a deep foundations? So these are very important justification judgment before initial construction or during the design and analysis stages. So very important. It says that here it's crucial part. And the next one is a field load test. The field load test is coming to you the bearing load test, or what we call it here, plate bearing test. We want to estimate the load the load effect. The load effect can give to you the settlement on site. So it's the predictions of the settlement. The next one is a conservative design. Why is this conservative design? And when you compare to the Terzaghi formula, based on the failure mechanism of on the Mendel provides the exact solution for undrained bearing capacity of homogeneous soil. So why it is not relevant to use this formula? Because in reality, your structure here just now was built on two-layer strata. The two-layer strata is not applicable anymore to the Terzaghi formula, which assume that the soil is homogeneous. So the soil homogeneous carrying the same properties and using the exact solutions. So not to forget, when you are proposing any design analysis for your forensic problem, you have to come up with a few assumptions that lead to you a solutions. Through the assumptions that can give you a good decision making to choose the right formula and also the right design to be adopted in your analysis calculations. When you adopt a wrong formula and wrong assumption, that can lead you to wrong justification and wrong judgment. Must be careful at that stage. So in this case, a conservative prediction may be achieved by assuming that the soil is homogeneous with the undrained shear strength of the weaker layer. Ini adalah second mistake in the analysis. It is assumed that the soil is homogeneous and carrying the undrained shear strength. So please, when you are doing the calculations, you have to identify, is it the structure can sustain for long or short-term stability. If you're choosing for the long-term stability, what are the best formula or assumption that can be get involved in your design stage? Is it possible to use undrained shear strength with the Terzaghi formula? Or you can use any Hansen formula, or you can use any other formulas that letters that relates to the site description or to the case description. Anything or the last lesson learned from this case history is an upper bound limit analysis using a simple kinematic mechanism that can provide a useful tool for determining an upper bound for bearing capacity of foundation on layered strata. So it is the very useful suggestion that can be carried out. Instead of using the conventional analysis using Terzaghi method or Terzaghi formula, better you use upper bound limit analysis. So this is the suggestion for reading. Okay, for the excavation, I leave it to you to read by yourself. So I think that I will end my class here, because if you look at to the learning activities, it's actually have splitted in the cases into few weeks. For example, this week will be involved with the settlements and bearing capacity failure. So you have to write up a report, a short report, and do a short presentation and record the video and submit to the UFuture in comment section. And then I will be uploaded all the videos to my YouTube channel. So you can view your submitted video from the channel. And for the next following weeks, we will dealing the geotechnical failures in slope, for example, and then any kind of the excavations. So remember, as I said just now, if you can produce a good forensic engineering report, is actually when you are involving with the what we call it, on-site investigation. On-site investigation, you go to the site failure, and then you collect few sample from the site, conduct testing, and then if you have more money, you can do some post exploration soil work just to get the info post failure, and then the importance of the post failure to be a parameters input in the numerical model. So these are what we can relate when you are producing a report. Not to forget also, when you are preparing a report, there must be a proper guideline that we try to follow with. For example, the public authority says that the construction can be constructed few meters from left and right existing building, for example. And the noise pollution cannot be exceed from this dBA. So these are the authorities guidelines that being followed during the mitigation process. And then what are other things besides the guideline, besides other things? So you have to you have to what we call it to concentrate all over aspect when you are proposing a work, from the beginning, causing and effects, and then producing a mitigation works. So all those information are blend together in one report. Okay, do you have any questions before we end? Ada tak soalan?
No, madam.
Madam.
Okay, just to ask every one of you here. Last time in chapter 2, how did you do the activity, or how do you capture the information from the chapter? Macam mana awak buat? Class session macam mana buat?
Buat summary, madam.
Somebody dari mana ke mana? Apa yang nak disamarikan? You all summary apa?
Summary based on case failure.
Case failure masa chapter 2 apa? Structural Okay, apa yang selalunya awak buat? Awak refer mana? Summary tu macam mana dalam A1 paper ke? Kemudian awak just submit kepada madam through MT ke? Macam mana you buat? Ke tak buat langsung?
Submit through MT, madam.
Okay, submit through MT kan? Saya nak tengok. Okay, setakat ni berapa orang yang submit? Lepas tu berapa duration? Berapa lama? Nak buat summary tu?
Sampai Ahad.
Rehat. Makna kata, sebab kan as I said earlier kan, your class approach for this course is a true case history approach, case history based. You can be in depth to the situations, phenomena as a forensic investigator or forensic engineer when you have your own site experience plus your lab experience. So how do you do that when you as I said lah, when you become an engineer, it is more interesting to do a report. But then as a student, how do you put yourself to summary a report that you have not been involved directly? How do you do that? Is it difficult? Then how are you going to further explain and to blend all the informations? For example here, okay, kebetulan saya buka Nur Ain Ain tak marah lah nah. Case study Highland Tower. Okay, ceritanya lebih kurang sama. 7 slide. Yang ni saya minta 5 slide. Lebih kurang lah. And then Madam Aniza asked you to take any cases in Malaysia, right? Okay, the chronology. Mana kita share, tengok apa ada. Okay, look, you have chronology, and then chronology, if you look at to the notes, it's actually is a case descriptions. A glance idea, a glance view of point. What are you trying to stated in your report? And then you can highlight the causes triggering to the failure. And then what are the additional info? For example, here, Nur Ain gave the information when it was occurred, at what time, and then how many blocks involved, and then the last thing that can be seen from the side. If you see from here, if you do some details investigation post failures of this building, the building became a haunted block, right? So nobody's stay in the condo anymore after the collapse failure. And what are causes here? Let me see. Because what we want to see, the important thing that you can taken or highlighted from the study. Causes. Okay. Okay, the block 1 became unstable due to soil erosions and landslide. The piping was insufficiently strong to contain the extra water. Had you recorded any rainy season in the past few weeks before the failure occurred? Okay, she mentioned here, she stated, in December 1993, the area experienced a prolonged period of heavy rainfall. It should be at the first one. Okay, and landslide began after prolonged period, correct? Right. So the important facts are there. Hypothesis. What are hypotheses here? Human errors were found to be dominant in triggering the landslide. And potential causes of failure included inadequate drainage, rubber wall failure, and what? It is now recognized as a structural failure. Okay, this is your hypothesis, right? How do you prove that your hypothesis is true or not? When you're talking about the hypothesis, it must be one hypothesis says it is true, one hypothesis says it is wrong. Null hypothesis, one or correct hypothesis. So this hypothesis not given any options. Is they direct jump to the conclusions. Evident. How does this UNIS support the hypothesis? The finding also confirmed that whether the safety factor of the slope is high or low, there is always possibility. Okay. Okay. This is not enough. Sorry to say, just my opinion lah, because the failure already occurred, and I think that if there is no mitigation or anything, that you must be highlighted why the mitigation is not undertaken during the time, and what are the assumptions involved. Assumptions involved for mitigations, and then what are the informations regarding to the or anything that can support your hypothesis in terms of the design, in terms of the analysis. I am not sure. Maybe the criteria set by Mrs. Aniza is not what I want from all of you, but it can be acceptable as long as you understand what you are doing. But now, can you see that just now you are focusing, you did focus on the structural failures. For this topic, you can bring the same case in history in the next chapter 3 as the geotechnical failures. How do you connect the structural failures to the geotechnical failures? So if you can see from here, if you see on the causes of the collapse, okay, it should be highlighted, the structural failures. For example, she mentioned here is a rubber wall failure. Okay, good. Rail pile foundation failure. So if it is good if you can elaborate more on the image, how does these failures occur for pile and also the rubber wall. And when you go to the next chapter 3, you can talk the same case history, but then you need to top up the informations from the geotechnical knowledge, such as the soil profile, and then the strength of the soil during the time. If you do the mitigations, what are the strength of the soil and the current of the time? So, and what are the mitigation, the suitable mitigations to being carried out in the future? Okay, this is one example. Okay, so far I can, okay. If you, let's say there are any options in my your future, I stated you have to choose from any newspapers cases. So I hope that you can take from there one case only that relates to the geotechnical failure according to the weeks given. Week 6, week 7, week 8, and week 9. So if you do not have any more questions, I will end our class session today, and we're going to resume our class next week. Anything you would like to ask? So actually, kalau you tengok dia punya durations, satu learning tu saya letak 8, satu learning activity 8, 9 minggu contohnya. Contoh pada minggu ke-8, kat situ saya highlight pada slope failure dan excavation failure. So 8 tu dia membawa kepada excavation failure. 9 tu dia membawa kepada slope failure. So weekly punya activity lah maksudnya. Tapi kita boleh merujuk kepada 2 learning activity saja. My expectation is that you're going to post or you need to give a feedback in the video form in the 4 videos from different types of geotechnical hazards. Okay, I think that we end here. Assalamualaikum and having a good day.
Waalaikumsalam. Thank you, madam.
Thank you, madam.
Madam.